Hello everyone, welcome to Biotech Notebook. This video covers how to balance a chemical reaction. First, let's see what is chemical reaction, then why we should balance a chemical reaction. Okay, so chemical equation is a symbolic representation of a chemical reaction using symbols and formulas. Then this chemical equation uses chemical formula for reactant on the left hand side and product on the right hand side. Okay, then this reactant and product are separated by an arrow mark, and this arrow mark indicates the direction of your reaction. Then chemical equation should be balanced. Why? Because it should follow the law of conservation of mass. Okay, so it says that same number of atoms of each element on both sides. Okay, the number of atoms in the reactant should be equal to number of atoms in your product side. Okay, if you follow three simple steps, you can easily balance a chemical reaction. Okay, so the first step is just make a column. Okay, so left hand side is your reactant, so just write the atoms present in your reactant side and product side. So here you have nitrogen, then oxygen. Okay, so in product side also you have nitrogen and oxygen. Okay, then the second step, count the number of atoms. Okay, so nitrogen here 2, so this is your subscript N2, so number of atom is 2. Then oxygen you have 2, so in product side nitrogen 2 and oxygen is 1. In reactant side, number of nitrogen atom involved is 2, number of oxygen atom involved is 2. Then product side, number of nitrogen atom involved is 2, but oxygen atom is here only 1. So we have to balance this reaction. When you balance a reaction, you can't change the subscripts of your chemical formula. Okay, so this is your chemical formula of your nitrous oxide. In product side, you need 2 oxygen, then only it will balance. So you have to put in front of your chemical formula as 2. Okay, so now you have 2 oxygen. If you don't have any number in subscript, means it is 1. So 2 into 1, 2. So there are 2 oxygen now. But now the number of atoms of nitrogen is changed in your product side, because here the number of atom is 2 into 2. 2 is 4. Always you have to multiply your coefficient. So this number you put in front of your chemical formula is known as stoichiometric coefficient. Okay, so this stoichiometric coefficient describes the total number of molecules involved in your reaction. Okay, so now your nitrogen is 2 into 2, 4. Okay, so here also you have to change. So now it is 4. So if you multiply this with 2, you will get 4. So put 2 in front of nitrogen. You can't change this as 4. Okay, so to get 4 number of nitrogen, put 2. So 2 into 2, 4. Now you have 4 nitrogen, here also 4 nitrogen, and 2 oxygen, here also 2 oxygen. Now your equation is balanced. So your balanced equation is 2 nitrogen plus oxygen gives 2N2O. 2 molecules of nitrogen reacts with 1 molecule of oxygen and it gives 2 molecules of nitrous oxide, N2O. Next equation is Fe plus O2 gives Fe2O3. Okay, so first step, left hand side write atoms present in your reactants and Fe and oxygen. Okay, and right hand side is your product side. Here also you just write Fe and oxygen, and the second step is count number of atoms involved in the reaction. So iron is 1, in subscript also 1, coefficient also 1. Oxygen you have 2, here 2, oxygen is 3. Okay, and the third step is balance the reaction. Okay, when you balance a chemical reaction, first starts with metal. First balance metal, then non-metal, then hydrogen, then oxygen. If you follow this approach, it is easy to balance a chemical equation, because metals are found only in one compound on each side of the equation, so it is easy to balance first. Whereas hydrogen and oxygen are appear in multiple compounds. So here we have written first metal. Iron is a metal, so first write in metal. Non-metal is not there, hydrogen is not there, so oxygen. Okay, so first starts with metal. So you have 2 iron here, so but here only 1. Just multiply 2, so 1 into 2, 2. So just put as coefficient 2 Fe. Okay, then balance oxygen. So here oxygen is 3, here oxygen is 2. Okay, so 2, 3. So find a common multiple for 2 and 3. So common multiple is 6. Okay, so just multiply here with 2, get 6. then here with 3 we will get 6. Product side you multiply with 2, so just put 2 here, 3. Okay, so now let's count total number of atoms, 2 and 2 Fe. Here 2 into 2, 4 Fe, so it is changed as 4. Okay, so now we have to change this side also. So here change your coefficient 2 as 4. Okay, so 4 Fe. So 3 into 2, 6 oxygen, 2 into 3, 6 oxygen. So your equation is 4 Fe plus 3 O2 gives 2 Fe2O3. Okay, 4 Fe, 2 to 4, 3 into 2, 6 oxygen, 2 into 3, 6 oxygen. Okay, next equation is MgOH twice plus HCl gives MgCl2 plus H2O. Okay, so the first step is let's start writing your atoms present in the reactants and products. So order should be first metal, then non-metal, and hydrogen, then oxygen. Okay, so here metal is Mg, magnesium, then chlorine, Cl, then hydrogen, and then oxygen. Same here also you write Mg, chlorine, hydrogen, then oxygen. Okay, so second step you just start counting the number of atoms. Okay, so Mg is here 1, here also 1, then chlorine is 1, here 2, hydrogen, so here hydrogen, so here OH twice. Okay, so open bracket, close bracket, then 2, so this 2 is common for O and H. So 2 hydrogen. Plus one more reactant is here. This also has hydrogen 1. So 2 plus 1 is equal to 3. So here 2. Then oxygen 2. Here 1. Okay, so first start with metal. So metal is balanced, then non-metal. So here you have 1 Cl, here you have 2 Cl, so you have to change it as 2, so multiply by 2, so 1 2s are 2. Okay, so put in front of your reactant, so 2 HCl. Next hydrogen, here 2 hydrogen, here 2 hydrogen, so totally 4 hydrogen. So this side you have to change it as 4, so if you put 2 you will get 4, 2 into 2, 4. Okay, then oxygen, so oxygen this side 2, here oxygen is changed to 2. Okay, so 1 into 2 is equal to 2. Okay, now Mg is 1 1, 2 2, 4 4, 2 2. So now the equation is balanced. Okay, AgNO3 plus calcium chloride CaCl2 gives AgCl plus CaNO3 twice. So here you have polyatomic ions in your equation. So CNO3, here also NO3. So this polyatomic ion is present in both right hand side and left hand side, that is reactant side and product side. Okay, so you can consider this atom, that is NO3, as a single unit. Okay, so if you have polyatomic ions in both reactant side and product side, you just consider it as a single unit, so it will be easy for balancing a chemical reaction. Okay, but in the last problem we didn't consider polyatomic ion as a single unit, because in reactant side only you have a polyatomic ion, but in product side you don't have OH, polyatomic ion. Okay, so this point also you should remember when you balance a chemical reaction, that is if you have polyatomic ions both in reactant and product side, you can consider it as a single unit. Okay, so now just write the atoms. So here, so first write all polyatomic ions, so NO3, then your metal Ag, calcium, then chlorine Cl. Okay, so here also NO3, Ag, calcium, then chlorine. Okay, my second step, just count the number of atoms. So NO3 is here 1, here it is 2, then Ag 1, here also 1, calcium 1, here calcium 1, then chlorine is here 2, Cl2, so 2, here AgCl, Cl is 1. Okay, so first let's start balancing this NO3. So you have 2 NO3 this side, so here also you should have 2, so 1 into 2, 2. Okay, your Ag is 2 side. Okay, so this side also you should have 2 Ag, so just put 2 Ag. Okay, then calcium is same 1, here also 1, and chlorine is 2, so here it is 2. Okay, 2 Ag, 2 Cl, so 2. Now the reaction is balanced. The next equation, AlOH thrice plus H2SO4 gives Al2SO4 thrice plus H2O. In reactant side you have two polyatomic ions, one OH minus then SO4 2 minus. But in product side you have only SO4 2 minus. So just consider SO4 as a single unit. So just write SO4, then your metal Al and hydrogen, then oxygen. Okay, here only one SO4 and this side you have 3 SO4. Then aluminium, this side only 1 and here you have 2. Hydrogen, so 3 hydrogen plus 2 hydrogen, so totally 5 hydrogen. So this side you have only 2 hydrogen. Then oxygen, 3 plus 4, so you have 7 oxygen and this side you have, here you have O4 and after your closed bracket you have 3, so you should multiply 4 into 3, 12. Okay, so here number of oxygen is 4 into 3, 12. Okay, plus 1, so 12 plus 1, 13. First balance your polyatomic ions. So this side you have 3, so here also you should have 3, so put in front of your formula. So 1 into 3 is equal to 3. Then aluminium you have 2, this side 1, so this also you have to change as 2. Okay, so 2AlOH3. So next balance your hydrogen. So already you have 5 hydrogen, it is changed here, 2 3s are 6, 2 3s are 6 plus 3 2s are 6, so it is changed to 12 hydrogen. Okay, so on this side you have only 2 hydrogen, same 2 hydrogen. So to get 12 you should multiply with 6. Okay, so 2 into 6, 12, so you will have 6 H2O. Then oxygen, here you have 2, then 3, 2 3s are 6 plus here 3 4s are 12, so 12 plus 6, 18. This side 3 4s are 12 plus this 6 oxygen is equal to 18. Okay, so oxygen is balanced and hydrogen balanced and aluminium Al is balanced, then your SO4 is also balanced, so your equation is balanced. Okay, so you have to continuously adjust your coefficient and you have to recount the number of atoms until the number is same on both your reactant side and product side. Okay, next question, NH3 plus O2 gives NO plus H2O. Okay, so write the name of the atoms. Reactant side N hydrogen, then oxygen. Okay, and then product side N hydrogen, then oxygen. Now count the number of atoms. So nitrogen is 1, hydrogen is 3, then oxygen is 2. Okay, so this side N is 1, hydrogen is 2, then oxygen is here 1 and here also 1, so 1 plus 1 is equal to 2. Nitrogen is balanced, then balance hydrogen. Hydrogen is reactant side 3 and product side is 2, so common multiple is 6. So to get 6, just multiply with 2, so 2 3s are 6, and in hydrogen, so product side you just multiply with 3, so you get 6, both reactant side and product side. Okay, once again you repeat the step, again check with nitrogen because now we changed the coefficients. Okay, so reactant side you have 2 nitrogen. Okay, so 1 into 2 is equal to 2, so you have to change in product side also, so multiply with 2, so put coefficient as 2, so 1 into 2 is equal to 2, so 2n, 2n, so now n is balanced. This hydrogen is same, 2 3s are 6, 3 2s are 3s are 6. Repeat with oxygen. So oxygen, this side 2 oxygen, this side here you have 2 oxygen, 2 plus here 3, so you have 5 oxygen. So now you have to change this as 5, so for that just multiply with 5 by 2. So if you multiply with 5 by 2, 2 will cancel it out, then you will get 5. You put 5 by 2 oxygen. Okay, But in your chemical equation, your coefficient should not be a fraction. To change this fraction to a whole number, just multiply the whole equation with 2, because here denominator is 2. So if you multiply with 2, 2 will cancel it out, then you will get 5. Okay, so just multiply with 2, so you will get 4 NH3 plus, if you multiply with this 2 will cancel it out, then you will get 5 oxygen is equal to, so this side also you should multiply with 2. So 2 into 2, 4 NO plus 2 into 3, 6 H2O. Okay, so balanced equation is 4NH3 plus 5O2 gives 4NO plus 6 H2O. Reactant side you have carbon, hydrogen, then oxygen. So in product side also carbon, hydrogen, oxygen. So carbon have 4 number, and this side only 1, and hydrogen 8, this side 2, and oxygen 2 plus 2 is equal to 4. This side 1 and here 2, so 1 plus 2 is equal to 3. First let's start with carbon. So here you have only 1, but here you have 4 carbons, so just multiply with 4, so 4 carbons. So next hydrogen, here it is 8, but here it is only 2, so 2 4s are 8. Okay, so 2 4s are 8. Now check with oxygen, because we changed the coefficients. So oxygen, this side is only 4, and this side you have 4 oxygen plus 2 4s are 8, so 8 plus 4, 12 oxygen. So here totally you have 4 oxygen, so here you have 12 oxygen. So here C4H8O2 plus oxygen, here you have oxygen alone. Okay, so if you change in this, there won't be any change in your carbon and hydrogen. If you change coefficient of this reactant, then there will be a change in carbon and hydrogen. But if you change the coefficient of oxygen, there won't be any change in these carbon and hydrogen. So change in this, here you have 2, so 12 minus 2 is equal to 10. Okay, already have 2, so if you subtract this from total number 12, so you get 10. If you put 5, you get 10. 5 2s are 10, so 10 plus 2, 12. So this side you have 4 plus 8, 12, so both the side 12 oxygen. Okay, 5 2s are 10 plus 2, 12, so 4 plus 8, 12. Okay, hydrogen is 8, here also 8, then carbon is 4, here also 4. So equation is balanced. The next sum, P4 plus O2 gives P2O5. Just write the name PO. So this side PO. So here it is 4, oxygen is 2, P is 2, oxygen is 5. So let's start with P. So here you should have get 4 number, so 2 into 2 4, so just put coefficient as 2, so 2 into 2 4. So now number of oxygen atom is changed as 2 5s are 10. Okay, so this is 10. So here you have to change, to get 10 just multiply with 5, so 5O2. Okay, so P4 5 2s are 10, 10 oxygen, 2 5s are 10, 10 oxygen. So now your reaction is balanced. To balance a chemical reaction, first step is just write the name of your atoms present in the chemical reaction, reactant side and product side. Okay, and the next step is just count the number of atoms in your reactant and also in your product. Okay, then the third step is start balancing. Always balance in this order, that is metal first, then non-metal, and then hydrogen, then oxygen. So this order is just to simplify your process. Okay, then you have to continuously adjust the coefficient, then you have to recount the atoms until number of atoms is same on both reactant side and product side. Okay, then one more point you have to remember is, if you have polyatomic ions on both reactant side and product side, then you consider it as a single unit. Okay, thank you for watching my videos. If you like my videos, please do like, share and subscribe.